Hey everyone, and welcome. Today we're jumping into a topic that's literally all around you, every single day, the chemical family of acids, bases, and salts. We're going to break down what they are, how they work together, and why they matter so much. All right, to really get a handle on this, we're going to use a super simple analogy. I want you to think of acids and bases as the chemical parents of the world. And when these two parents get together and react, well, their children are the salts. This whole family idea, it's going to be our guide through this entire explainer, so keep it in mind. So here's what's on the menu to do. We'll kick things off with our chemical family story. Then we'll get to know the parents, acids versus bases. We'll take a trip down the pH scale, bust a big myth about salts, and wrap it all up by finding this family in our everyday lives. Sound good? Let's go!
Okay, so first up, a chemical family story. What actually happens when our two chemical parents meet? Well, it's not just a casual get-together. They have this one super important reaction. You can think of it like a chemical marriage called neutralization. And it's really a simple story. Step 1, an acid meets a base. Step 2, they react in this process called neutralization. And step 3, what do they make? Two totally new things, a salt and water. That's the core equation to remember. Acid plus base gives you salt plus water. This is like the main event, the big family reunion.
All right, we've seen the family dynamic. Now it's time to properly meet the parents. What really makes an acid and a base a base? Let's find out.
So let's talk about acids first. Their entire identity boils down to one simple thing. When you put an acid in water, it releases hydrogen ions. H+ ions. That's it. That release of H+ is what makes an acid, well, acidic. And on the other side of the family, you have the base. It's basically the counterpart. When a base dissolves in water, it releases hydroxide ions. That's OH-. So you've got the H+ from the acid and the OH- from the base. These two are the real stars of the show when that neutralization reaction happens.
But, we don't always have to think about ions. We can actually tell them apart in much simpler ways. Take taste, for example. Acids are sour, think lemons. Bases, they're bitter, like baking soda. How about touch? Bases feel kind of slippery, almost soapy, but acids can be corrosive and stinging. And of course, the classic lab test, the litmus test. An acid turns blue litmus paper red, and a base does the opposite, turning red litmus blue.
So, okay, we know what they are, but how acidic or how basic is something? How do we measure their strength? Well, for that, we've got something called the pH scale. And I love this analogy. Think of it like a family mood ring for chemicals. It tells you exactly the personality of a solution.
So let's take a little journey down this scale. It goes from 0 all the way to 14. Down at 0, you have the super strong acids. We're talking battery acid level strong. As you move up the numbers, things get less acidic. Like milk is around a 5, so it's only weakly acidic. Then you hit the magic number, 7, which is perfectly neutral. That's pure water. And once you go past 7, you're in base territory. Baking soda is a weak base, around 8. And if you go all the way to the top, to 14, you've got the really strong bases, like bleach.
And let's just pause on that number for a second. 7. This is the most important point on the entire scale. A pH of exactly 7 means something is perfectly, totally neutral. It's that perfect balance point, and it's the pH of pure water.
Okay, we've spent a lot of time with the parents. Now, let's turn our attention to the children, the salts. And you might think this part is going to be simple, right? But there's a huge myth that we've got to bust wide open. So here's the big question for you. If salts are born from a reaction called neutralization, doesn't it make sense that all salts would be, well, neutral? That they'd all have a pH of exactly 7?
And the answer is a big surprising no. This is honestly one of the most common mistakes people make. Not all salts have a pH of 7. And the reason why is actually super interesting and tells us so much more about this chemical family. It all comes down to a process called salt hydrolysis. It sounds complicated, but it's not. It just means that the ions from the salt can actually react with water and, you guessed it, release either some H+ or OH- ions, which totally changes the pH. It's almost like the salt's child inherited a really strong, dominant personality trait from one of its parents.
See, it all depends on how strong the parent acid and base were. If you have a strong acid and a strong base, they're perfectly matched. They cancel each other out and you get a neutral salt with a pH of 7. Makes sense, right? But if a strong acid meets a weak base, the acid's personality is just too strong. It wins, and you get an acidic salt.
And you can probably guess the last one. A weak acid plus a strong base, the base wins, and you end up with a basic salt.
Now, we mentioned litmus paper earlier, but that's not the only trick chemists have up their sleeves. There are other cool indicators, like phenolphthalein. It's colorless in an acid, but turns this amazing bright pink in a base. Or methyl orange, which goes from red to yellow. But my favorite, and this is pretty wild, are the olfactory indicators. Things like onion or vanilla that literally change their smell depending on if they're in an acid or a base. How cool is that?
Okay, that's a lot of chemistry theory. So let's bring it all home. Where does this chemical family actually pop up in your world, in your everyday life? Let's take a look.
You'd be surprised. Acids are everywhere. That car battery that starts your car, it's powered by sulfuric acid. The acid in your own stomach digesting your lunch right now, that's hydrochloric acid. And that awesome sour taste in a lemon, you got it, citric acid.
And what about bases? Oh yeah, they're just as common. You know that slippery, soapy feeling of, well, soap? That's because of a base, usually sodium hydroxide. Ever had nasty heartburn and taken some milk of magnesia? You just used a base to neutralize that stomach acid. And of course, baking soda. It's in pretty much every kitchen out there.
And finally, the children, the salts. We all know table salt, right? Sodium chloride, but they do so much more. Ever broken a bone and gotten a cast? That's made from a salt called plaster of Paris. And the fertilizers that help grow our food? Packed with salts like potassium nitrate. They're literally lifesavers and world feeders.
So there you have it, the whole chemical family. You've got the parents, acids and bases, and the incredibly diverse children, the salts. And this isn't just stuff you read about in a textbook, right? These reactions are happening all around you, and even inside you at this very moment. So I'll leave you with this thought. Now that you've officially met the family, what chemical reactions are you going to spot in your world today?